The James Webb Space Telescope has sent Earth a huge admonition, and it's drawing nearer. This warning comes from the exoplanet Proxima b, and with each new picture sent back, additional inquiries emerge, leaving specialists unnerved. Each description of this far-off planet makes us wonder more about the secrets of the universe. Growing inquiries are emerging about a potential hostile planet close to Earth. Might there be an adjoining alien planet with antagonistic intentions? Could Proxima b ever represent a danger to our very existence? The subject of alien life has intrigued humankind for hundreds of years. Yet with modern technology like the James Webb Space Telescope, it has become an inquiry we can explore more fully than ever before. However, the universe isn't making it easy to find answers. We continue to use our best devices, such as the James Webb Telescope, to capture glimpses of far-off planets and worlds, hoping to find pieces of evidence that may point to life beyond Earth. We must be realistic, however. Every new picture and piece of data generally reminds us of how little we really know. While these discoveries could be monumental, they also highlight the infinity and complexity of the universe, leaving us with more questions than answers. Grasping a distant planet like Proxima b could rethink our place in the universe. For scientists and astronomers, this is exciting, but for the general population, it often feels like just another piece of space news, far off, exotic, and sometimes overwhelming. These discoveries raise more questions than they answer, leading many to ponder how this affects life on Earth. Could Proxima b truly harbor life, or even intelligent life that could one day present a threat to us? Notwithstanding the massive power of the James Webb Space Telescope, it can only show us so much. Sure, we've learned a few incredible things, like the fact that we now have stunning new pictures of Proxima b, and we know that the universe is much bigger than we ever imagined. But what comes next? The potential ramifications of these discoveries can feel as vast as the universe itself. Proxima b, discovered in 2013 due to its gravitational interaction with its star, was a significant scientific breakthrough for many researchers. Finding this exoplanet was like discovering a new cosmic neighbor. Proxima b is just slightly larger than Earth and orbits its star every 11.2 Earth days, making it a captivating subject for further investigation. From a scientific standpoint, the idea of a distant world so close to our own is thrilling. But for most people, it's difficult to connect with a place that is 25 light-years away. To put that into perspective, even the fastest spacecraft humans have ever made would take tens of millennia to reach it. Imagine what it might be like to stand on Proxima b. Its star, Proxima Centauri, would appear as a faint red light in the sky, much cooler and darker than our Sun. Proxima b orbits so rapidly that a year there lasts just over 7 Earth days. One side of the planet always faces the star, meaning it is locked in perpetual daylight, while the other side remains in eternal darkness. It sounds like something out of a science fiction novel, but the reality would be far more extreme. On the bright side of Proxima b, any water would likely boil into steam due to constant exposure to heat. On the dark side, however, the water would freeze into solid ice. Proxima Centauri, the planet's star, is also not a quiet and stable neighbor like our Sun. It throws out dangerous flares and intense radiation, making the surface of Proxima be a hazardous place for life as we know it. This isn't the kind of neighborhood where humans would want to camp out. Interest in finding life beyond Earth peaked in late 2020 when researchers detected an unusual signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had a unique frequency of 982.551 MHz, which caught everyone's attention. Such a signal could theoretically be a sign of advanced technology, but it's still too early to draw any conclusions. More recently, the James Webb Space Telescope has fueled even more excitement by suggesting that Proxima b could have water vapor in its atmosphere. Water, as we know it, is a key element for life, and its presence could be a game changer. To better understand how much water is present on Proxima b, researchers are using advanced techniques like spectroscopy. This method allows them to detect the gases surrounding the planet, acting as a modern investigative tool. By analyzing the planet's light spectrum, scientists can identify specific gases like oxygen, methane, and carbon dioxide, all essential for life. Atmospheric modeling is another key approach. By using virtual simulations of Proxima B's climate, researchers can make rough estimates about its conditions. These models serve a similar purpose to how scientists use fossils to hypothesize what dinosaurs may have looked like. However, the more we learn about Proxima B's environment, the more we are reminded of the incredible variety of living things that exist here on Earth. Extremophiles, for example, are tiny organisms that can survive in extreme conditions like boiling hot springs, acidic lakes, and the freezing cold of Antarctica. These resilient organisms show that life can adapt and thrive under conditions once thought impossible. Could life on Proxima B be similarly adaptable? The search for life on Proxima B presents enormous challenges, not only in terms of space travel but also in proving that life can exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere may not offer much protection. Moreover, the distances involved are so vast that new types of propulsion systems are necessary to make space travel to Proxima B possible. Ideas like solar sails, ion propulsion, and even more speculative concepts like warp drives offer exciting possibilities for future exploration. However, these advancements are still in their early stages and require extensive research before they can be used in real missions. While dreaming about future space travel is exciting, we need to remain realistic. Finding life on Proxima B is fraught with technological and scientific difficulties. Only by advancing our technology and expanding our understanding of the universe can we hope to unlock the full potential of distant worlds like Proxima B. This pursuit isn't just about satisfying curiosity. It's about pushing the limits of human achievement. Might we one day set foot on Proxima B or even make contact with life there? As we contemplate the long journey to Proxima B and beyond, discovering extraterrestrials no longer feels confined to the realm of science fiction. It now seems like a real, tangible possibility. This fascinating shift from a distant dream to a scientific mission has garnered serious attention from cutting-edge organizations like Breakthrough Initiatives. These groups are dedicating enormous resources to turning what would normally be an incredibly lengthy journey, one that could take millennia using today's technology, into a feasible mission within decades. The goal of reaching another star system within a human lifetime has sparked significant advances and fueled optimism among mainstream scientists. However, these lofty aspirations are quickly tempered by the stark realities of our current technological limitations. Despite remarkable progress in space exploration, traveling to Proxima B or even Alpha Centauri, which is just 4.2 light-years away, still presents daunting challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey possible in any reasonable time frame. Breakthrough Starshot, one of the most notable projects, envisions using powerful laser-driven sails to propel small spacecraft to speeds of up to 20% of the speed of light. While this concept shows promise, it is still in the experimental phase and faces numerous technical and logistical hurdles, such as protecting the spacecraft from space debris and ensuring reliable long-distance communication. While the dream of reaching Proxima B and potentially discovering alien life is closer to reality than ever before, it is still constrained by the limitations of current technology. Accelerating a spacecraft to near light speeds with today's tools feels nearly impossible, like trying to solve a difficult puzzle in the dark. Even ambitious projects like Starshot, which aims to send a spacecraft to Alpha Centauri using lasers, face significant practical challenges. The Earth's atmosphere causes disruptions for the lasers, making it difficult for space exploration devices to work with the required precision. One proposed solution is the use of adaptive optics, smaller lasers on satellites that continuously monitor and adjust for atmospheric disturbances. This system would help powerful ground-based lasers stay focused on the spacecraft as they travel through space. However, the laser propulsion method requires an enormous amount of energy, comparable to the total energy consumed by the entire United States, and it would only work for a brief period. Imagine setting up 100 million lasers over a vast area just to propel a small spacecraft, only 33 feet wide, to 20% of the speed of light. At this speed, the spacecraft would still take 22 years to reach the Alpha Centauri system, a time span longer than many people's lifetimes. Yet the challenge of reaching Alpha Centauri isn't just about overcoming technical barriers. There are natural obstacles as well: the gravity of the sun, the presence of space debris, and the sheer enormity of the distance involved all pose significant risks. Even communicating with a spacecraft en route to Proxima b would require sending messages through time, as it would take around 4 years for a signal to reach it from Earth. Despite these daunting challenges, the desire to explore other star systems continues to grow. It is driven by humanity's deep-seated love for discovery and exploration rather than practical necessity. Even ambitious projects like Starshot, which aims to shoot a spacecraft toward Alpha Centauri using lasers, face numerous practical hurdles. Nonetheless, solving these problems could revolutionize space exploration. Still, the potential dangers involved, such as communication delays and natural hazards, demand careful planning. Despite the difficulties, many scientists believe the rewards far outweigh the risks. Finding life on Proxima b or another distant exoplanet continues to captivate minds around the world. Finding life on another planet would be the greatest scientific discovery in human history. It wouldn't just reshape how we see ourselves and our place in the universe, but could also offer insights into the origins and future of life on Earth. While humanity dreams of a future where we can travel to the stars, we are also taking practical steps in our search for life. The discovery of planets like Proxima b is just the beginning. Telescopes like Kepler have been crucial in identifying distant worlds that could potentially support life. By observing how these planets interact with their stars, either by blocking a portion of the starlight as they pass in front or by causing the stars to wobble due to gravitational pull, we can learn more about their size, composition, and potential habitability. Now that Kepler's mission is complete, the James Webb Space Telescope is stepping up to take over. Its ability to detect infrared light allows it to study planets that were previously too faint or too distant for us to analyze. As we learn more about Proxima b and other exoplanets, we are expanding our understanding of the universe, and with it, the possibility of life beyond Earth. The James Webb Space Telescope has opened new doors in the search for extraterrestrial life, especially with the discovery of exoplanets like Proxima b. While we are still in the early stages of investigating the potential for life on this distant world, the technology and curiosity that drive us will continue to push the boundaries of what we know. Whether or not Proxima b harbors life, the mission to understand it has already reshaped our perception of the universe and ourselves. As we dive deeper into the mysteries of the universe, the quest for extraterrestrial life takes on new significance and urgency. The advancements in technology, especially in observational cosmology, have enabled us to peer farther into the universe than ever before. Instruments like the James Webb Space Telescope are transforming how we understand planetary systems, allowing us to analyze the atmospheres of distant worlds and uncover potential signs of life. One of the most fascinating aspects of Proxima b is its location in the habitable zone of its star, where conditions could allow liquid water to exist. This region is often referred to as the Goldilocks zone, where temperatures are neither too hot nor too cold, making it a climate conducive to life as we understand it. Scientists believe that if Proxima b has the right atmospheric conditions, it could potentially support living organisms, even if they differ significantly from those on Earth. Furthermore, the study of Proxima b opens a window into the conditions that may have influenced life on our own planet. By analyzing the geological and environmental characteristics of Proxima b, scientists can gain insights into planetary formation and evolution across different star systems. Such studies could shed light on the processes that lead to habitability, providing clues about how life could emerge under varying conditions. Astrobiology, the field dedicated to the study of life in the universe, plays a crucial role in this investigation. Researchers in this field are not only focused on finding life but also on understanding the potential for life to adapt to extreme conditions. This knowledge could enhance our search for life in places previously considered inhospitable, such as the icy moons of Europa or the methane seas of Titan. The energy surrounding Proxima b is not just about the possibility of finding life. It also highlights humanity's innate desire to explore and understand our place in the universe. As we contemplate the potential existence of intelligent life forms, ethical considerations come into play. If we were to encounter extraterrestrial civilizations, how would we communicate? What protocols would we establish to ensure mutual respect and understanding? Moreover, the cultural implications of finding life elsewhere are profound. Such a discovery could challenge existing beliefs and philosophies, prompting a reassessment of humanity's role in the universe. It could inspire a new era of collaboration, as nations and organizations unite in a shared quest for knowledge and exploration. As our understanding of the cosmos expands, so too does our fascination with the potential for life beyond Earth. The search for extraterrestrial life is not just about finding another form of existence. It's about understanding the fundamental principles that govern life itself. Each discovery, whether it be a new exoplanet or the possibility of water vapor on Proxima b, pushes the boundaries of what we know about life's adaptability and resilience. Scientists are increasingly exploring environments that were once thought to be inhospitable, such as the acidic lakes of Venus, the methane seas of Titan, or the frozen oceans beneath the ice crust of Europa. These places, though vastly different from Earth, may harbor forms of life that are completely alien to us in both structure and function. The idea that life could exist elsewhere is deeply intertwined with the search for knowledge about our own origins. If life can exist under extreme conditions on other planets, it may provide clues about how life began on Earth and how we might sustain it in the future. In fact, studying these distant worlds could help us answer some of the most profound questions humanity has ever asked. Where do we come from? Are we truly alone in the universe? And if we are not, what does that mean for our future as a species? With each new advancement in technology and space exploration, we edge closer to answering these questions. And even if we never make direct contact with extraterrestrial life, the journey of discovery itself continues to enrich our understanding of the universe and our place within it.